Good morning. As you said, I'm the Director of Systems at Joint, a cloud infrastructure company. We go by a variety of monikers depending on which quarter you ask us. I've also in the past been a member of the OpenSlayer's governing board, and I was in the pilot project, and I've been around way too long. Wanted to start off the event looking kind of at our little map here. It is daunting. I assume everyone's seen this at some point, I hope. It is overwhelming, and it is also very exciting. And I think it's a great way to frame this entire event in terms of the stack. Anything that I talk about in my presentation or that we talk about throughout the day and to some extent throughout the SNIA event will in some way relate to this. And it's such an interesting group of things. It makes me always want to wear my chef's jacket because it makes me feel, it reminds me of people actually have to work for a living, and also kind of brings together an idea of what we do, which is taking the best components, the best ingredients, and slicing and dicing them into something really interesting and useful that people enjoy. So my presentation is going to be on cloud computing. Just out of curiosity, how many people think they know what cloud computing is? How many people think that anyone knows what cloud computing is? How many people think that it's just a bunch of marketing crap? Hello, hallelujah. So I was curious exactly what I should present on. I love iSCSI. I could talk for days about iSCSI alone. And I didn't really want to do the whole cloud thing because, you know, I'm here as a member of the community, not just as a shill for my employer. But there was an interesting video. I don't know if everyone's seen this, but this was from the Sun Analyst event they did for storage a couple of weeks ago. And this is an interview that I'm going to show you between Mike Shapiro, who's sitting in the back of the room, and Stephen O'Grady, who's an analyst for RedMonk, who's been very, very good to Sun, and I'm sure a lot of you probably know him. So I'm going to play this little clip, and then we'll start into the presentation. We'll see if the audio works.
Primitive tools, where do you start? Or you just end up with people saying, well, it's not the network.
Yes.
But that's all I know. Yep. And I can't really say any more than that. Yep. You know, and that actually brings up another question I have, because I think, you know, one of the things you have to do as an analyst is look at, you know, where are we going? How are these things changing? And, you know, one of the things that we see in terms of the different kinds of customers you talk to is, you know, in very traditional large customers, I sort of think of segments of, you know, there are the people who manage operating systems and boxes. Right. There are the people who write applications, the people who manage switches and networks,
sure.
And then the sort of traditional storage people.
Yep.
In a lot of the smaller companies you deal with, yep. Those boundaries don't really exist. You know, one future question I have for you is, do you think that will continue to be? In other words, as some of these companies grow larger, do you think they sediment internally into those same structures, or does that?
I actually don't.
Do these new companies continue to be different?
No. I think the trend that we're seeing certainly in the marketplace is, you know, with the advent of cloud computing, a lot of the typical scaling tasks that startups have struggled with essentially are being outsourced to cloud providers. Right. So rather than some of these very small companies that don't necessarily have the resources, either don't really want to go out and acquire them, you know, at the cost that they command, will essentially make that somebody else's problem. Right. So that's one of the primary advantages to cloud computing,
right,
and to that approach is that, you know, for many of them, it obviously depends on the provider that you choose. Amazon, for example, a lot of scaling is still on you. You still need to know how to wire together the individual pieces. But something like Google App Engine, basically your implementation is all that you need to be concerned about. The scaling is now somebody else's problem. And ultimately, I think that's the trend that we'll see. So rather than a lot of these startups, you know, have to go through the same pains of recreating individual resourcing departments and divisions to handle all of these separate tasks, which frankly are very different and require different skill sets, different investments, different certifications, different hardware experience, and so on. I think increasingly they'll seek to outsource that wherever they can.
Yep.
So the point being there that Mike asking how various startups and whatnot are going to handle storage going forward, and the answer being that they're going to outsource it to the cloud. So storage in the cloud. This is going to be in two different parts. The first part is going to cover what the cloud is in general. The cloud. One of my favorite comments about cloud computing actually came out of frustration during a conference call we were having among our senior staff with a difficult client problem. And he said something, and I won't say who, said something really interesting, which he said, is it a cloud or is it a puff of smoke? Which generally tends to summarize how things fall down. So what is the cloud? Highly virtualized. Generally, when we talk cloud, we're talking virtualization. It's built from commodity building blocks, x86 server, standard disk. One of the defining features is that it's highly, easily, and quickly scalable, or as Amazon has popularized the term, elastic, and moving much closer towards the capacity on demand model, which is something that the industry has been after for years and years and years, this idea of capacity on demand, and never really quite delivered. Various people have varying degrees of success, but that's what we're moving towards. Now, I say optionally API control. If you go to a cloud event, there was recently a cloud camp in San Francisco a couple months ago. And most people who were there were there for no other reason to try and define the cloud. What is a cloud? And the groups tend to sediment on this one issue, API control. Amazon EC2 is best known for that. You can programmatically expand, grow, contract, whatnot. Puts a lot of control in the hands of the developer. Not everyone agrees on that point, and we'll talk about that a bit more. One of the key issues here, as was alluded to in the video we just looked at, is it's someone else's problem. To some extent, cloud for a lot of customers is nothing more than outsourcing in a new and interesting way that's a bit more palatable. So there are really two large perspectives on what cloud is. The first is the web developer. The web developer wants to scale programmatically, quickly adapting to changing traffic situations. When they decide in their application code that it's time to scale, that they need additional capacity, the last thing they want to do is pick up a phone and talk to a really cranky, long-haired IT guy who's just going to tell them we can't for a variety of reasons. They want to be able to do it themselves, send a SOAP call to some nifty new WSDL, and it just kind of magically expands to meet the need. The other side is the enterprise customer, who's looking to acquire additional resources quickly and cheaply to extend the existing infrastructure. They're not looking to replace their internal data centers. What they really want to do is be able to access new and fast hardware to do development and whatnot. There are a lot of web developers. It's a lot of the new startups you see. There's countless numbers of them. Enterprise customers include PayPal, for instance. We got an interesting abuse claim, actually, that there was a PayPal spoofing site as one of our customers. Looked into the issue, and it was actually registered to a PayPal employee. We thought, okay, somebody's messing with us here. And the page actually really did look like a spoofing site. We went through the process, and it turned out it actually was PayPal owned. Their developers were frustrated by how long it took to get internal resources and decided to just go and pay for an account with us and do all the development there, and then bring it in-house and, hey, it's already done, it's ready, it's baked, it's fully tested, it's been out there in production. It was a very hard thing to do and interesting. What's especially interesting is that apparently this is so common a thing that when you dial PayPal's corporate number and you hit the option 4 for HR, there actually is an option in the menu just for validating whether or not somebody actually works for PayPal. So is it evolution or revolution? We like to break a lot of new things down into these categories. It really is evolution, and it's fueled by marketing. It's a lot of marketing crap, I'll be honest with you. I view this as the continuing convergence of HPC with mainstream server computing. Right? This is something we've seen since, I don't know, 95, 96, some might say earlier than that, where we continually see this movement to take what's been learned in HPC and distill it down into the enterprise to varying degrees. And this is just, I think, the next evolution of trying to do that, especially as we break out into commodity parts. We need to now manage, instead of having one big Spark server that cost us, $500,000, sorry, son, we're now buying cheap machines and distributing widely, which means we suddenly have problems like, say, HPC. How do we do deployments under very large numbers of machines? How do we keep things consistent? How do we find bottlenecks in a large grid, right? Which is funny, actually. When I wrote the slide, the word grid came to mind. This kind of faded out of the consciousness quite a bit, I think. It was a big push for a long time, and I think that was the last phase of the HPC movement. The cloud movement is just the next piece. The other is that it's web pace, right? This is a term we see more and more. Combining virtualization into the mix. Virtualization makes it hard for traditional acquisition practices to keep up. One of the classic problems is just, like I said, with PayPal, is trying to acquire resource quickly to keep up with your various needs. Development needs, production rollout needs, especially as web demand is very, very kind of flaky. Businesses, grow or die overnight in a lot of cases. Twitter, I'm sure everyone's heard of Twitter. Twitter is an excellent example. They were a customer of ours. And their first big push was at South by Southwest. We get a call from them halfway through the conference that their traffic has quadrupled by midday, and they expect it to go 4 times that by the end of the day, and they need to grow very, very quickly. These are opportunities where, especially with a lot of the startups, your customers are very, very flaky, right? The first time they hear about it, they go and try it out. If it works well, they get excited. If it doesn't work well, they have a bad taste in their mouth from then on out, and it's very, very hard to grow your business, especially if you get a big plug from, say, the Wall Street Journal, right? Walt Mossberg is, I think, probably one of the best sales engines there is out there, right? If Walt's going to write about you, you need to grow quickly. And going to your traditional vendor, trying to acquire new hardware, get it set up and rolled out can take weeks, especially just depending on the size of your deployment. Cloud allows you to meet the needs much more quickly. So, everyone loves the film Soylent Green, right? Customers are particularly interested in CPU, memory, and disk, right? When it comes to virtualization, you start breaking things down. In a virtualized environment, you're not really concerned about whether it's a Supermicro, a Sun, a Dell, an HP. You're very concerned about CPU, memory, and disk. They really don't care what it is anymore, right? Because if you're running some type of hypervisor on top of your hardware, who cares what's underneath, just so long as you get your resource. They want it to be cheap. They want it to be fast. What it is doesn't particularly matter. So what you really need when you look at a cloud provider is you're looking at somebody else to architect something that allows you to concentrate on what you're interested in, which is that CPU, memory, and disk, and takes it out of your hands. So the cloud, in a lot of cases, is really, we're talking about people. That's the outsourcing component of it. Somebody else doing the hard work, keeping up with new technologies, migrating the infrastructure over time in order to meet your needs. Because when you have this virtualized thing, who cares if iSCSI is behind it, Fiber Channel over Ethernet is behind it, Fiber Channel is behind it, right? It doesn't really matter, so long as it's really fast. And what's killing a lot of shops these days is just trying to keep up. So it's kind of, in a lot of ways, especially with the enterprise customers, it's about freeing up your IT. The clouds allow IT departments to focus on solving internal problems rather than keeping pace with technology details. Upgrades are better and faster. They're trivial. You just redeploy. Because when you have a virtualized instance, if you need something faster, you get a new account. You upgrade your account. Somebody else takes care of all the hard work of actually upscaling onto the new platform. You're not as interested. We're starting to see the beginnings of abstractions between customers and vendors, like I said, right? If somebody comes to Joyent as their cloud provider, who cares whether we're running Sun underneath or not, right? If they're unhappy with the service, they move over to somebody else who may be using another vendor. In a lot of ways, this plays into Jonathan's predictions from the days of yore, when he was projecting that one day end users will never go to a company like Sun or HP or IBM. You'll go to a provider, what we're today calling a cloud provider. You'll get your resources from them, and they'll in turn go back. In a lot of ways, it'll start looking like the telephone companies or the electrical companies and the whole utilitarian design that he was really pushed for a long time. And we're starting to see it move that way, especially as everything standardizes on commodity x86. There are pushes, for anyone who's interested, there are pushes for Niagara. We actually have looked at selling Niagara services. People are very uninterested in it, particularly because it breaks the ability to move quickly from one place to another if you're using Spark binaries. We can talk about details of performance of Niagara if you want, but this is a Sun event. I want to be nice. Integration and innovation. The cloud transforms hosting companies into systems integration companies of the 21st century, I think. There always used to be a debate around Sun as to whether Sun was an integration company or an innovation company, right? And I don't know if those debates still go on internally. You look at a company like Dell, they're clearly an integration company, right? They're one of the best manufacturing companies in the world. They do it very, very well. They don't do anything particularly interesting. But they do produce servers very, very quickly and exactly the way you want. It's great. Look at Sun's business and a huge amount of innovation been going on, right? In two very different sorts of realms. A lot of the existing cloud companies, you'll notice, were hosting companies 2 years ago. And when the idea of cloud came around, all the hosting companies sat down and said, okay, cloud is coming. How do we take advantage of this? And at first, it was nothing but marketing, right? Products didn't change, nothing revved. But we're not a hosting company. We're an infrastructure company, right? We're a cloud company. We're interested in the cloud. We don't do hosting. And it's slowly kind of moved as the hosting providers have picked up more and more the virtualized technology, moved over from thin solutions to more standardized solutions, whether it be VMware, Xen, Zones, OpenVZ, or other options. And try to glue all these components together in a new way, right? Generally, we're taking existing components, some type of hypervisor with an operating system of some kind, and then gluing all those things together, generally with a web interface, web panel, an API, what have you, in order to make a compelling solution that's easy for customers to use. And it's generally driven by customer demand. So this is one of the big reasons that no one really knows what a cloud is. If you ask a cloud provider, and they're actually really honest, the answer will probably be whatever the customer wants it to be, right? In a lot of ways, there's a lot of parallels between where we are now and where the server industry was back in, say, like the early 80s. And as we start to grow, I think in probably 5 to 10 years, the idea of buying a server will be a bit dated, right? It's just a legacy model, right? Salespeople coming in, trying to help you out, trying to help you to design a solution. At some point, all those people go away, and you're left with something. With a cloud, you're not left in that lurch. You always have people there to help you. So an example, Box.net. Very cool company. It is the easiest way to share and manage your files online. Now, the reality is it's an integration style company. It's a web front end Isilon HTTP storage. That's not proprietary information. It's in one of their white papers. Very, very simplistic, right? Isilon, if anyone's familiar with Isilon, they do HTTP storage very, very well. And in a sense, the web front end is just sort of proxying traffic through to the Isilons, and the Isilons do their thing. It's a very, very interesting and lucrative business, I believe. And they're an example of a business that's built on relatively simple integration, and they're transforming a product into a service. Another example would be Amazon S3. It's API-based storage, right? Just got a file descriptor and dump things into buckets. The underlying architecture is out of sight and out of mind, right? People debate exactly what the underlying architecture is. It really doesn't matter. No one really cares. And it's an example of a business that's more interested in innovating to serve a particular niche. And I do believe that S3 is a niche. There are some people who would disagree with that. But the reality is most people who believe that S3 is sort of for everyone are actually using applications that were written to use S3. There are very few people who are just going to buy S3 and use it as is, right? Because it is API based. I think that there are also a lot of parallels between appliances and clouds. The attractions are fairly similar, I believe. Someone else is doing the hard thinking, and allows customers to focus on productivity. When it breaks, it's somebody else's problem, and it's generally a pay-as-you-go, ease-of-use sort of thing. The world is getting more complex all the time. It's getting harder, and people are being asked to do more and more with less and less resource. And anything that can be done to help them is definitely welcome, especially when it comes to storage. You got a lot of people who are very good with operating systems in IT departments. They're very good at selecting the servers and managing vendor relations and stuff. But particularly in the area of storage, which was kind of nice and quiet for a number of years and has really heated up in the last two, you start seeing things like iSCSI all over the place, IS&S, fiber channels kind of going, or we're seeing IFCP and fiber channel over Ethernet, SAS, SATA, as well as traditional options of fiber channel. The industry has exploded quickly, and suddenly I think there's a lot of people in IT departments who are just being buried under this. Now, it's an excellent opportunity for a lot of the big storage vendors to come in and say, don't worry, we'll help you. If you don't know what it is, EMC is here to save the day. People are less interested in that, particularly with some of the big vendors like EMC. It's just too expensive. And as there's been a real explosion in the number of startup companies, they're just not willing to shell out like that. Especially as VC tends to be kind of hard to come by, and if you have access to VC, why would you waste it on a really expensive NetApp or EMC, right? Appliances are a great way to go for in-house storage. Clouds would be, to some degree, the parallel out in the net. Plus, ultimately, most of these startups are now directly servicing the net. So your storage is already there. So now we'll go into storage and virtualization. Are there any questions so far? Okay. So virtualization in general. The software that most people are using today is fairly diverse. VMware ESX, Xen, Zones, OpenVZ, which would also be known by its commercial name as Virtuoso. If anyone wants to call Zones Solaris containers, I'm sorry. In this case, we're talking about server virtualization solely. We're not talking about desktop virtualization because it's boring. These pieces of software are very good at delegating access to CPU, memory, storage, and networks, providing all these things to the operating system in a regulated sort of way. Hypervisors, as they're sometimes called based on the context, do a very good job actually of managing CPU and memory, but they really don't do so good at managing the storage and network today. It's slowly improving, but there's still, I think, a very long way to go in terms of resource control and auditing and whatnot. The common environment that you tend to see in the data center these days for customers who are really building out on virtualized platforms tends to be 1 to 2U servers between 4 to 8 cores, typically dual socket servers. They're building out, it was a lot of AMD that's fallen away, and a lot of people are now adopting Intel in droves because of the success of their quad core. It tends to be 8 gigs of memory up to 32. You don't tend to see more than that. Between 4 to 8 local SAS or SATA drives, typically depending on cost, right? Everyone would prefer to have SAS if they could. Raw and local disk capacities tend to be largely sacrificed by segregation, right? So you have a server with 8 disks, which is great, but typically, you want to break off 2 to mirror for your root disk, so now you're down to 6. Then you tend to want to RAID 5 or 6 that, so you end up losing another. I think because of this, Sun bet really big, I think, on 2.5-inch drives, which I think was extremely premature. The capacities are still far too low, which just means that you need more drives. And so on this one issue of local disk, I tend to see a lot of people push towards Dell. Of course, side issue tends to be what kind of RAID controller you have available. And the market tends to be dominated in the data centers these days by Logitech or Adaptec. Logitech, did I say Logitech? I meant LSI. LSI being vastly superior to the Mega SAS product. The Adaptec product has provided widespread chaos. The standard interconnect tends to be gigabit Ethernet. InfiniBand is extremely uncommon. The only times I see in the data center people running InfiniBand in virtualized environments like this tends to be if it was vendor supplied. They go out and buy a blade solution from IBM, which is very, very rare. I don't see IBM a lot, but they tend to buy like a large blade solution that happens to use InfiniBand. If they go with some of the clustered storage solutions from, say, 3PAR or Isilon, it may have InfiniBand backend. But other than that, it's very, very rare to see anyone do InfiniBand to the server. It's just too expensive at this point, and is a technology that very few people properly understand and are willing to commit to. Fiber channel is degraded to legacy. I've never heard of a startup deploying on fiber channel. There are a number of customers who still use fiber channel because they've had it in place, but I don't see anybody ordering it if they didn't already have it. So you tend to see a lot of it move to gigabit Ethernet. As I said, the common RAID controllers tend to be Adaptec and the LSI Mega RAID, which is preferred. They're cheap enough these days that just about anyone's going to order them. Centralized storage, there are a number of excellent high density, high capacity, low cost options, particularly Thumper. Since Thumper's announced, there's been, I think, a dramatic increase in the number of other suppliers who are trying to supply Thumper-like storage, meaning mid-grade workhorse x86 servers with 4+ CPUs and as much disk as they can possibly throw on it. The problem with centralized storage tends to be that the virtualized workloads are generally highly random. At least they look highly random to centralized storage, and it tends to kill your performance. Thumper and similar solutions tend to tempt administrators into creating very, very large storage pools, right? When you've got 48 disks local, and you've got 24 tera raw, you tend to want to just make one big pool, and you can just dole it out any way you want to, right? So very, very efficient and kind of future-proofed. And the problem is that at some point when you start throwing, when you dish this out as virtualized storage, right, all those are actually root disks, right? And in some cases, people are swapping onto those shares, right, which are centralized. So the amount of I/O occurring in your centralized storage is insane. Generally, because of the fact that it's spread out, your network's okay. But access to the disk tends to be really, really nasty. And it seems like a great idea when you start out. It seems very simplistic, very easy to manage, and it gets more complex as you utilize it more and more. I think that's only going to increase as we see centralized storage grow in capacity, right? Suddenly, the rate we're going, it's not going to be long before we're talking about 100 terabyte, devices that are for you, right? I mean, if you put, you got 48 if you put terabyte drives in a Thumper today, and that's going to double very, very quickly. When you combine, so when you put a large number of clients on those centralized storage. Like I said, what you tend to see is that in terms of performance, you spend a lot of time seeking. The disks are very, very busy, and your throughput is very, very low. Copy on write only makes it worse. And so you really, the number one thing you want to do is the classic storage performance solution, which is reduce head movement as much as possible. And unfortunately, because the back-end storage capacity has increased so much, caches really haven't been able to keep up, right? I mean, we still, like, a good cache size is like, 256 megs of cache, which doesn't mean quite so much now when you have several terabytes behind it. It used to be really nice, which is one of the reasons that things like ZFS Level 2 ARC is very, very exciting. I'll talk a little bit more about ARC, actually. So in terms of interconnect, iSCSI, the land of milk and honey, the golden solution that will make all of your problems go away, make you happy. iSCSI is particularly exciting when it comes to virtualization. There are a lot of parallels between virtualization and the types of storage problems we actually had with diskless clients, right? In ways, it's the same thing, just in a new era. So iSCSI really allows virtualization, or let me turn that around. Virtualization in general really is all about storage. As far as I'm concerned, virtualization is storage, 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 right? CPU and memory can be anywhere. Your instance, what you are, is a bit of storage. You move that storage around and attach it to different CPU and memory, and you go, right? Moving from one piece of hardware to another is trivial. You just detach from this CPU and memory and attach to another server that hopefully has more CPU and memory. So it's all about the storage. That's you. And so the faster that you can move between this, between different end nodes, the better, right? Which makes iSCSI just perfect, right? Put your storage off somewhere else. Centralized would be nice, but it doesn't really work so well. And when you want to move from one piece of hardware to another, you shut down your instance, zone, your ESX instance, what have you. Shut it down, move the target over to another machine, and boot it back up. And you've just moved, right? And that you can do that in seconds. So iSCSI it really is a promised land for virtualization, especially at least when you're talking about IP storage. So migration's just totally become a dream. IS&S takes on a whole new life, actually, because now you can direct where you want your servers, your virtualized servers, to be running through something like IS&S. So now IS&S kind of becomes a director. And iSCSI is, I think, one of the things that's really interesting to me is it's being increasingly used as what I'll call a gateway protocol. CleverSafe is doing this. Amazon's Elastic Block Store, which is block storage built on top of S3, now use iSCSI interfaces. And I actually think that's interesting. We started seeing kind of so many different things like this come up, became an office joke, hey, does that Post-it note have an iSCSI protocol available? So I think iSCSI is going to be used in more and more novel ways that I don't think many of us really expected. Of course, iSCSI does bring challenges. Block storage across the network is great, but thanks to the availability of open source copy on write file systems, you get this kind of interesting cow-on-cow action going on with the magically multiplying blocks. This is a problem we've seen in places where we, say, ran ZFS on top of a NetApp. NetApps are horrible. We didn't want to buy them, but we were kind of early, and we sort of felt we had to, and we needed something we knew could do iSCSI very well, very early, which we now regret. But when you tend to run something like ZFS on top of Waffle, what you tend to see is things multiply. So you look at the amount of I/O that you've actually done, and you look at the amount the back end of the storage has changed, and there's 4 times order of magnitude change, which makes things like replications very, very interesting. One of the other problems, of course, with the iSCSI is that block file systems in general don't like unreliability. OSs really hate it. And so if your storage goes away, your system panics. And every virtualized instance on the machine is no longer accessible, which is a real scary sort of thing, right? Especially as you increase the density of virtual instances on a given machine. When you have 30, 60 virtual instances, you really have to be very careful that one of them doesn't cause all of them to panic. The hypervisors do a very, very good job of making sure that, that problems in one virtualized instance don't affect another. But if the backend storage goes away, Solaris in particular is very good at saying, oh, look, data corruption. Tell you what, I'm going to do you a favor, and I'm going to crash, right? Which makes one very happy that his data didn't get corrupted and he didn't return bad data. Every other customer is really pissed. One of the other things with iSCSI is we've been playing with iSCSI a lot for what I call iSCSI stacking, which is using iSCSI as a way to make storage building blocks accessible through a variety of abstraction layers. So that would be some of our early testing, which was done when the iSCSI target was way too immature, was taking ZVols on thumpers, exporting them as iSCSI targets, going to another front-end machine, which was then had an initiator to both those targets, and then created yet another Z pool on top of those that mirrored them and dished that out. We thought, oh, this would be really great. It'll be very redundant and nifty, and it was a disaster. But iSCSI does allow a lot of interesting kind of interconnecting sort of things that happen behind the scenes that we're very interested in. And I think that people will experiment more, especially as a lot of the both target and initiators tend to mature. So centralized disk is great, but just really isn't feasible. So local disk tends to come back into the picture. DAS, if you prefer. But generally, the internal capacities to these machines are high enough that we don't need DAS. So local disk is very, very fast. Drive capacities and densities are rapidly increasing, especially in the workhorse class servers. We're seeing 400, 500 gig drives are now standard fare. People are pretty happy with them. We're seeing 8 drives plus available in a workhorse machine in the standard $5,000 to $10,000 range, which a lot of people are deploying. Like I said before, 2.5-inch drives are exceedingly fast. They're super fast. I love them. But the capacities are way too small for the real world. They kind of throw you back a couple of years. So 3.5-inch drives are still the way that people want to go, just due to drive capacity. So one of the advantages of local disk is not only do you have these large capacities, but you have access to local disk caches. If you have a RAID controller, you have access to those. Write-back caches are wonderful, wonderful things, and they're now cheap and battery-backed. So you get a lot of benefit from using local disk, especially in a virtualized environment, especially if you're running a database, which is very I/O intensive. Local disk is definitely the way to go. It's significantly faster than any IP storage solution you're going to come up with, unless you're using InfiniBand RDMA or something like that. The problem, though, is of course, now you've got these kind of pools of storage out there, right? So this idea of being able to take your virtualized infrastructure and move it quickly from one place to another kind of goes out the window, because now instead of just repointing your storage to some other place to move your instance, you now have to go through this kind of complicated replication exercise, which depending on your technology can be very, very difficult. This is one of the reasons that ZFS comes out head and shoulders above everything else. I don't mind saying that if it weren't for ZFS, Joint probably wouldn't exist. We wouldn't be we wouldn't have the capabilities that we do, and we wouldn't be the size that we are. Everything that we do is effectively an exercise in the use of ZFS. When we create new instances or new zones for customers, it's actually a cloning exercise. We have a standard template, which is set up in a variety of configurations. When we set up a new machine with whatever version of OpenSolaris we're using, right now we're standardized on SNV89 because of the new Intel quad cores. We create a Z pool on local storage, and then we replicate in all of our templates. When a customer requests a new zone, what we're actually doing is a ZFS clone of that template. We then have a bunch of scripts that go in on top and customize, set up redundant MySQL, things like that for customers, and then push it out. When we migrate from one place to another, that's ZFS send receive. Backups are ZFS send receive. So you end up with a number of problems when you've got the local disk, right? Like I said, you have these islands of storage, classic problem that we run into every couple of years, which means that you need to start looking at this as a distributed disk. So generally on most machines, you tend to have, you use all the local disks that you need for all the instances that you can run. And you tend to have 100 gigs or more available left over that you don't need, simply because of the drive capacities, which would be really nice to use in some way. Generally, when you size a server in a virtualized environment, you're sizing it based on CPU and memory, not disk. So if it has a little disk or a lot of disk, it doesn't really matter, generally. The most important metric when it comes to any virtualized environment is memory. Memory is the most valuable thing in the data center, especially if you're a provider, because you're selling generally based on memory, right? You need to isolate a certain amount of memory that's locked down for a given instance. Once you've utilized all that memory, it's over, right? And you have to lock those things in for certain customers. So memory may be almost completely unused, but if it's already been allocated, that's it. Very few vendors tend to want to oversell. We don't oversell at all because it becomes very, very dangerous. Applications don't like it when they try to go for memory and it's not available. The result is underutilized isolated storage that is really fast. So distributed applications frequently require some type of centralized storage, but very, very rarely. So how can we take all these kind of bits and shards of storage out there and bring them together? It's a very difficult thing to do today, but there are a number of things kind of on the roadmap that we're really interested in. PNFS is very, very exciting. We're waiting for that to come down the pike. iSCSI stacking, like I said, being able to combine all these different things as iSCSI targets and export them up and create bigger things. Project Celeste. If you haven't heard of Project Celeste, you really should check it out. It's kind of a descendant out of the Berkeley Ocean Store stuff. It's a very exciting project. HDFS, which is Hadoop, and friends like that. These are kind of API-based storage, distributed storage solutions, which are still, I think, fairly immature. And a lot of us, particularly for like enterprise customers, are trying to figure out how to take advantage of this. It works really well from an API for your PHP app or your Ruby app, and so those kind of customers really dig it. For other people who just need storage to put files on, who aren't using some type of new developed in-house application, it would be a little more complicated. So those are things that are very interesting to us. But particularly Lustre. Lustre can't get here soon enough. We want Lustre so very, very badly, particularly Lustre ZFS. So one of the things in a distributed environment, a highly virtualized environment, is backup is really painful, exceedingly painful. ZFS cloning reduces disk consumption significantly. Like I said, right? I mean, you have a 1 gig template, let's say, and you clone it 30 times. How much storage are you using? A gig. The problem is when you replicate all those out, ZFS tend to receive those out, you lose that clone relationship. So if you have 30 1 gig clones, you're actually only using a gig of local storage. When you send those out to, say, your Thumper for a backup, you're now using 30 gigs. When you suddenly have thousands of instances in a data center, that really, really hurts. So deduplication would help. Cloning is I guess you could in some senses call it deduplication. So being able to maintain that relationship would be really nice. But in terms of backup, what we tend to find is that we're trying to stop looking at backup as a periodic copy and instead think of it as really slow, sucky, asynchronous replication, since that's really what it is. I mean, tar and rsync are evil. And what has continually shocked me over the years is no matter how much the industry has changed and how much we've evolved, GNU, tar, and rsync are still like the kings of data center backup. You can do it for free in-house with a couple of scripts, or you can go out and buy, Symantec, Norton 2000, whatever they call it these days, net backup, right, which is just a big wraparound GNU tar. It's really shocking that these are still like the solutions. And right, those are copy solutions. So we've spent a lot of time actually in-house looking at like various types of replication solutions and how we can use them to facilitate something that looks more like backup. Things like AVS and some of the SNDR Sun stuff is very exciting, except that when you do block replication of ZFS, when you bring up the remote copy, which you say maybe want one file back, it gets really mad, and your server throws up. And of course, then you break the replication, and you have to resync. It's really nasty. So ZFS send receives, though, can do some interesting things if you do them quickly enough. In general, the answer for us in terms of backup has always been, you've got to copy it all once. But don't ever do it again. Then you just need to make sure that your replication window is as low as possible. So in a number of cases, I've gone so low as I've gone to 5 minutes. I don't tend to like going any lower than that. But no matter how much data change, if you can replicate that change every 5 minutes, you have a pretty kick-in backup solution by backup standards, and it's really, really light on your network. It's really light on your storage. So moving into this mindset of how to facilitate backup and protection via replication is important. Of course, I will say one thing is backup is something that has been a really sore issue for a lot of hosting providers for years, right? It's something that a lot of people struggle with. And one thing I would recommend you do is if you got a hosting account somewhere, even an old one that you've had around, and you think that they're backing up your stuff, go read your SLA. That like agreement that you signed, you probably should like skip down to the bottom to the really small print, because it probably says that backups are your problem. And there tends to be internal debates at a lot of the different hosting companies who say, look, customers buy something, it's their problem. It's their stuff, they need to back it up. They're responsible for their own stuff, and they should have a copy of it, right? If something goes wrong, it's not our fault. The other internal argument, which the system guys tend to have, is, well, what if our stuff breaks? What happens, if the customer deletes a file, okay, it's their problem. They deleted a file, right? If they want a backup service, they should purchase a backup service. What if our own servers crash? What if our own storage fails? And those tend to get those debates get very, very interesting. It's evolving all the time, especially because hosting providers have so many clients and you have limited data center footprint. Not as many people are doing as backup as you think. I will tell you that like Amazon, they don't back up anything. So if you got your EC2 instance, make sure you keep a local backup of it because they don't back up anything ever. So best practices. I think this is one thing that I know I'm certainly interested in at this event and throughout the week at the SNIA event. Best practices take years to accumulate, particularly in storage. Storage in particular because you tend to set it and forget it. And if you want to make changes, it involves bringing things down, and it's not something you do very often, right? So you want to do it as best as you possibly can once and be done with it. And if there's any one guy who's going to make everyone in the company very, very grouchy, it's the storage guy tweaking in the middle of the night and dropping all kinds of different services and databases. Best practices rarely can keep up with new changes and new technology, right? I'm amazed by the number of people who still go back to like the old articles in I forget the name of the website, but they used to post things for Adrian Cockcroft. And I'm sure everyone's seen a lot of those old articles that Adrian did about NFS performance tuning. Like those are still like considered like the standard, right? These are like 10-year-old columns and articles and QAs about how to manage NFS performance, and like people still use them. Best practice is really lagging behind what a lot of things that are happening in particularly Open Solaris' storage stack, right? These things are so new. One thing that kind of hurt us for a while is this constant message that ZFS does not require tuning, which is simply not true. today. It will be, and it requires very, very little tuning. But there are a number of cases in which you do actually need to tune, and you do need to spend some time looking closely at it and what it's doing. One of the things that will kill you, particularly with iSCSI, is ZFS prefetch. ZFS prefetch is very, very aggressive. And ZFS arc is very, very efficient. It's disgustingly efficient. It's excitingly efficient. But if you have a very random workload, you can be doing a lot of I/O that you don't need to do. That may get rolled out of cache very quickly, particularly if you're not using things like level 2 arcs. So evolving with a lot of these things is new. I mean, iSCSI is a big one. There's a lot of people who want to capitalize on iSCSI, and they're not really sure how to deal with it. Do we need to use jumbo frames? Do we need to look at link aggregation? Is link aggregation actually going to do what we think it's going to do? Do we need to upgrade to optic networks, or is copper networks fine? Do we need to wait for 10 gig? And then I think particularly when we look at what we want to deploy today in terms of what's coming, right? We know 10 gigabit Ethernet is available today, but very expensive. We know that it's coming. But we're seeing an explosion of RDMA protocols available, like the iSeer, iSCSI RDMA stuff is really exciting. 10 gigabit iWarp, things like this. There's a big question mark out there. This is actually on my next slide. Yeah, when is it gonna hit? I mean, how far until we start seeing 10 gig become standardized and widely deployed? Some of the other questions I had on here, I kind of jumped ahead. QFS. Are there any QFS fans? 1, 2, 3. Anybody else want to pretend? QFS is an amazing storage product, But what was interesting was that QFS became available from Sun, and we're all very excited, and then they wanted you to pay for it, which is a real downer. And they've loosened up on that, and they open sourced it, but then we had ZFS. So QFS kind of looks old and tired. QFS still is an amazing file system that does some really interesting things, QFS and SAM. I know one thing that I'm very interested in is does QFS really have a future? I'd really like to see where that's going to go. Of course, some of the other questions looming in the future, ZFS licensing. Sun is teasing us, right? Let's post a picture of Jeff with Linus Torvalds and then not tell anyone what it means. And people are actually, like, there are whole articles. You can find articles on Google just based on the file names. Jeff and Linus.jpg. What does that mean? There's kind of a lot of questions hanging out there about what's going to happen. Is ZFS going to go GPL v3? And I know there's a couple of you in this room who probably know the answer, so feel free to tell us at dinner tonight. Linux ZFS, of course, is a big question too. Any of us who are big proponents of open Solaris, I know I, for one, am not really excited about seeing ZFS move over to Linux too soon. We can debate that. Like I said, it's a good dinner topic, Linux ZFS. But it is exciting to see all the interest around it, and the fact that Linus Torvalds, who's so opposed to things like GPL v3, sees ZFS and goes, I'd think about it. Right? That's an amazing thing if you know Linus. The future of I/O scheduling is a really big question. I/O resource control. That's something I think we lack tremendously today. Like I said, in a virtualized environment, there's one thing that I really can't control, and that's who gets to use how much storage, right? Everyone can do kind of whatever they want, and that's one problem we run into in the data center a lot. You have one particular person who capitalizes on a storage resource, and there's really nothing I can do about it except turn them off. You can have one of our smallest possible accounts, and you can run a benchmark on it and just saturate our disk. And all I can do is control the granularity of how many other customers you're going to affect. There are a number of other places where I/O scheduling would be really, really nice to have. I mean, ZFS does do a good amount of I/O scheduling, but not in the resource control sort of area. How exactly that's going to look in the future, I don't know. Linux does some I/O scheduling and resource control today. I don't think it's particularly great. I don't know if you're going to be able to say, this guy gets, 100 IOPS, and this guy gets 300 IOPS. It's going to be interesting to see how that comes down. Comstar's amazing enabling power. I know there are several of you that were on the registration list that are doing appliances. And I don't know if you guys are using Comstar today or not, but I mean, Comstar is going to be very interesting. I'm very interested to see what happens with Comstar uptake among kind of your standard Solaris sysadmin. It has a great ability for building appliances and things like that, but ZFS is going to abstract a lot of Comstar's details away from you, right? ZFS set share iSCSI on, and it's done. Did Comstar do it? I don't know. It just worked. But Comstar does have the ability to do some very interesting things, and I'm curious how deeply people are going to want to get into Comstar. And if you haven't played with it, I definitely suggest getting into it. The project iSeer is in fact the iSCSI target, so iSCSI, Comstar, ZFS today. As I talked about before, ZFS backup is, I think, one thing that's going to be really interesting to watch in the near future as we see replication improve. NDMP is in Solaris now, and how it's going to get utilized with ZFS more and more. And particularly, I'm curious, I know we're going to have presentations this afternoon on Zamanda, what a lot of the commercial backup vendors are going to do about ZFS. I know a lot of them say they support ZFS, but there's a big difference between backing up files that are on ZFS, woohoo, versus actually being able to manage ZFS send receives. Because backup in a ZFS environment really is managing replications, right? Managing ZFS send receives, not just grabbing files off disk. And of course, we talked about cheap 10 gig RDMA. So one thing that's definitely clear is the future is very exciting. As I showed the roadmap in the beginning, there's a lot of different things going on. It's extremely overwhelming. A lot of people right now are struggling to keep up with what's going on. There's a lot that's going on publicly. We also know that the Fishworks guys are busy away doing things. It is making a lot of people very excited and anxious to see what comes down the pike. And there's a lot of possibility and opportunity out there, but we have a lot of balls in the air right now. Storage is moving, virtualization technologies are moving, server technologies are moving. There's a lot these days to be very excited about, and it's definitely a welcome change from 2, 3, 4, 5 years ago, where it was a brocade and EMC world, and life would never change. Now it's getting a lot more fun. So, questions? No one, nothing? I mean, I try to be as confusing as possible so that somebody had a good question.
Can you go to the mic so we can all hear you and so they can hear you on Ustream?
So I have a clear shot if your question is back.
So you two talked about the open source APIs. Could you talk more about that? The APIs?
You got to walk 40 paces, dude.
Yes, you also talked about the APIs for cloud computing. Could you talk a little more about that? What are the standards for those APIs?
There are no standards. There are no standards today. Whether or not an API is required is highly debated. The most widely known available is for Amazon EC2. And so most people, when there isn't a standard, you just look at the most popular guy out there, right? And you go, well, what he does is what everyone expects, so meet that. There are people who are trying to come up with standards for cloud APIs. One of the most interesting would be Project Eucalyptus out of was it UC Santa Barbara. They're working on some work to try and standardize that. But honestly, I mean, I watched a standards effort go on with Ruby, and it's still hotly contended. I mean, things that are going to have standards tend to have standards very early, or they never really materialize, and then some organization grows up and everyone debates it. So it could be a long time before you see a standard. Anyone else? Go ahead.
Thanks. Get up to the mic.
Mark's totally cutting you off. Never mind. So one of the things that's interesting is at Joyent, we are, depending on who you are, we are either extremely cutting edge or really, really laggy. From the outside perspective, we look really cutting edge, right? We're running like, Solaris Nevada 89 in production, and we're okay with that. From like the Sun internal perspective, we're moving kind of slowly on things because while we adopt things quickly, we do have to be somewhat conservative because of stability, right? There's a lot of questions about stability. ADM is something that's relatively new to our eyes anyway, and something that we're exploring, but I'm not ready to jump on the bandwagon. One thing I love about ADM is if you go to that page and you see that wonderful diagram of about how like 40 different things fit together, you're like, wow, I have a 4-line bash script that does replications really well. So I really want this thing with all these moving parts and WSDLs. And anytime Java is too involved, I get scared. So ADM is something that we're looking at, but not something that we've jumped on board yet. I mean, there are other components, like I said, we spent time with AVS, looking very, very hard at AVS. In fact, we were so excited about the open sourcing of AVS that testing began about 30 minutes prior to the sources actually being put on OpenSolaris.org, because we kept beating them up. We're like, it's supposed to be released today. Where's the code? Where's the code? Where's the code? Right? And they actually gave us an early access to it. But an hour later, it released, and 2 days later, we had completed all of our testing. So we do jump on these things. Particularly, AVS was exciting because it was very, very mature. Right? It had been around a long time and was now available to the rest of us. But ADM will come slowly. I'm very questionable about its reliability. What up?
Would you mind talking a little bit about iWarp and what that enables and sort of what your thoughts on that are?
iWarp is the RDMA stuff on 10 gig. The actual internals of iWarp is actually something I'm secretly hoping to get a lot of details on this week at the SNEA show. One of the things, I meant to mention this in my slides, InfiniBand was this amazing thing, wasn't it? I mean, we might all have different opinions on this, but when I heard about InfiniBand, my understanding was the promise of InfiniBand is that you will now have one wire in the back of all your servers, right? 2 if you count the power, right? And no longer would you have all these these network ports spiraling out of control, right? I mean, like all of our machines have 4 Ethernet, depending on the data center. My hand and my brain disagree. 4 Ethernet cables into the back of each machine, right, for different networks. You've got the storage networks, you've got the private networks, you've got the public networks. Then in a lot of cases, we have an administrative network for either Dell Drax or Sun ILOMs, things like that. InfiniBand was supposed to make all this wonderful, it's all virtualized in this really fast network pipe that's way faster than you ever need. And there's RDMA all over the place, and you just have memory talking to memory. And it never really delivered, I think mostly due to cost and complexity. And so I'm really hoping that 10 gig, since it will come, it will be cheap, it will be everywhere, you will just buy a server one day and it will have 10 gig on it. I'm hoping that 10 gig will deliver all the things that we were supposed to get. And I see iWarp as largely, and Mike can correct me on this, as being all those sort of InfiniBand RDMA extensions onto 10 gig Ether to make it really sing. So. Anything else? Go ahead.
Okay, last question.
iSeer is really exciting, though. The RDMA iSCSI, really exciting. And the RDMA NFS is already out, which is really exciting. The demos are really cool. There are video demos on the website. Go ahead.
There's this OSD.
Excuse me?
OSD.
OSD. OSD is something I actually really hope to hear a lot more about during the show. So that's your object-based storage devices. The idea of storing intelligent objects instead of just storing, allocations of dumb blocks that require information about them. OSD, I think, is something that there's a lot of white papers out there on OSD, and you see a lot in terms of iSCSI providing access to OSD and things like that. But I've seen very, very little in terms of how we in the industry are actually going to utilize OSD, right? When I think of OSD, and actually I tend to think of things like Honeycomb with context storage, right? Where I say, I want something with a bunch of tags. Go and get it for me and bring it back to me. OSD, how exactly that's going to play out, I'm not really sure. There's a lot of papers on it. What's that? Excellent.
So what Peter said was SAMQ is going to be built on OSD.
Yeah, so SAMQ 5.0 is currently in development, and actually the ISER project is also delivering the OSD initiator, and there's the target that's coming as part of SAMQ 5.0.
Right. So I mean, I'm sure there's several of us here who would love, if somebody here wants to do a lightning talk this afternoon about not just getting access to OSD, but actually using OSD, would love to hear those kinds of talks.
Yeah, so if you want to hear about the OSD initiator and things, come and chat with me at some point. So I know a little bit about it, and I can point you towards some code drops that are available too. So.
But how does your application use OSD?
So, well, again, today the way that we're providing it in, well, we'll be providing it in Solaris is that you'll be using it through SAMQ 5.0, right? It's kind of similar to an SD target driver, or, you know, so the OSD initiator is built on top of the iSCSI target that,
right.
Sorry, the iSCSI initiator then talks to the iSCSI target backend. And, oh, yeah, talk to the mic. So essentially, so that's the way that it's built in today. So OSD initiator, iSCSI initiator that then talks to iSCSI backend, or it will be the ISER backend as well. And that's what SAMQ 5.0 is using, and that's the main consumer that we have today for OSD. But we're sort of putting it out there, and hopefully, you know, inquiring minds will figure out new and interesting ways to use the OSD initiator once it's out there.
So Peter Dunlap is giving a talk at the STC on Wednesday afternoon. It's called ISER, and that's the OSD stuff if people are interested. Okay, thanks.